All right, this is a little tricky, so hopefully this makes sense okay. We're going to be talking about sequences. So a sequence is nothing more than a list of numbers. And the list of numbers, each member of the list on here, 2, 4, 6, and 8, they're all referred to as terms. Um, and so the term is the numbers that make up the list, but we refer to them usually with an A and a subscript of N, where N is referring to the number of the term. So this one is going to be N right here. That's kind of, this whole thing is, it's got a lot of notation that you have to keep track of at first. But the idea is that this is a sequence. If you notice there are commas in between each of the terms, that's how you know it's a sequence as opposed to a series. If it was a series, the only difference is that instead of commas, that they would be added together. It would be a summation of this whole thing. So we're just looking at the sequence for now. And we want to be able to refer to all these different pieces and understand what all these letters and things mean. So if I think about this as my sequence, this is the first term of the sequence is 2, this is the second, this is the third, and this is the way we normally talk about ordered numbers, 4th, 5th, 6th, and so on. Well, this first, second, third, fourth, fifth, these are the N values. And so I don't actually use these superscripts on here. So I'm going to take all of these off. But just so you kind of understand what we're dealing with. So if I were to say N equals 4, then I'm talking about, if I were to say N equals 4, then I'm talking about this term right here. And so the fourth term of this sequence is 8. If I were to write that mathematically, what I'm saying is that A sub 4 is equal to 8. And A sub 5 is equal to 10. And we could even predict then, and say find the next term of the sequence, A6, I could say that one's going to be 12. Because of course we're counting by 2's, but really I just want you to see how the A and the subscripts work on this whole thing. So if I want to refer to any term, I would say A sub n. If I wanted to refer to the next term after that one, well, then I would use A sub n plus 1, right? Because if we look at this whole thing, so assume that n equals 5, well then this is my any term right here. If I add 1 to that, so I would have A to the 5 plus 1, well that's A6. A6 is this term here, and so by putting the plus 1 on the end, it switches it to the next term. It seems kind of simple, but it just looks confusing, to get it all together. One other piece we can put on here, let me get some of the stuff out of the way, is we could also talk about the previous term. And so for that one, we would say A sub n minus 1. Same idea, if we say that n equals 5, if I subtract 1 from 5, it becomes 4. Here's 4, and so this is A sub n minus 1. It went this way. It went to the previous term, and I put the minus 1 on there. So hopefully that kind of gives you an idea about how the A sub n plus 1, and A sub n minus 1 work, and what they're referring to in terms of these sequences. The way they work is actually pretty simple. This is saying write the first 4 terms of this sequence. All that means is that I want to evaluate this for n equals 1, n equals 2, n equals 3, and n equals 4. I stop at 4 because it says the first 4 terms. Well, if I do that, this is 2 times 1 plus 5. This would be 2 times 2 plus 5. This is 2 times 3 plus 5. This would be 2 times 4 plus 5. So I'm just, I have an n right here, and it becomes 1, then 2, then 3, then 4. As I plug in all the way down. And of course, to actually write my sequence, I would evaluate these things. I can see I'm generating a sequence of numbers that definitely has a pattern. Again, that's something we're going to talk about a little bit later. But my answer for this, if I was generating the first 4 terms of the sequence, it's going to be 7, 9, 11, 13. So that's the idea of how the A notation gives you the values of the sequence.